Okay, today while you're at home, I want you guys to take notes. We are going to be talking about inequalities, which are similar to solving equations. You just have those inequality symbols and you have to graph. So today is Wednesday, 11/4, and we are solving and graphing inequalities. Okay, so let's just go over some vocabulary as a refresher. And remember, while I'm doing these, if you need to pause the video or what have you to catch up, you guys know how to do that. All right, so we have greater than, which looks like this, right? And another word for greater than would be more than, right? We also have greater than or equal to, and that's when you have the greater than symbol with the equal sign as well. Some other ways to say that would be at least, minimum, or no less than. Okay, and these keywords will come in handy when we start evaluating like phrases and creating the inequalities. And then we also have less than, which of course looks like this. You might hear fewer than. And then we have less than or equal to. And of course that's the less than symbol with the equal sign. And some phrases you might hear there would be like at most, maximum, or no more than. Okay, so what we're going to do now is we're going to take these phrases. I'm going to give you like a little, take these vocabulary and these ways to describe these symbols, and I'm going to give you a phrase and you're going to tell me like how would that translate into an inequality. So if I have examples down here, and if I said at most $50, right? So let's say I can spend at most $50 at the store. Maybe it's the Apple store or something. So I'm going to look up here at my phrases, and I'm going to say, okay, where do I see at most? Oh, less than or equal to. So that tells me that X has to be less than or equal to $50 because that at most coincides with the less than or equal to. Okay, let's do another one. More than 25 tickets. Right? So then I would go back up here again, and where do I see more than? I see that that lines up with greater than, and I know you guys can't see it on the screen, but you should have it on your paper. So that means that X is greater than 25. X being whatever situation we're talking about. All right, let's look at number 3. Maximum of 123 people. So let's say we're going on a field trip and the maximum number of people I could have is 123. So when I look back up here at these phrases at the top of my page, I can see that maximum lines up with less than or equal to. So I would say X has to be less than or equal to 123 people, meaning that the number of people I want to take on the field trip would have to be less than or equal to 123. One more example. At least 80 miles. Okay, so if I'm going somewhere or let's say I'm training for something and I want to, over a period of time, run at least 80 miles. So where do I see that phrase, at least? If you look back up here at the top, it lines up with greater than or equal to. So X would have to be greater than or equal to 80, meaning if I'm going to train to run say a marathon, I would want to run at least 80 miles in training to prepare for that run. I'm not a runner, so maybe that's not very accurate, but that's what I would put. That's how I would interpret that. So this is page 31 for my notes. Okay, so that's the beginning of our solving and graphing inequalities. This should be review in theory. Okay, so let's now move on to solving inequalities. So now I'm on page 32. And we're going to start out pretty simple with some one-steps. So solving inequalities. So I have 3x is less than 15. Okay, so I'm going to do the exact same thing I would have done if this was an equation. I'm going to draw my wall of equality. I'm going to divide by 3 on both sides, and I get x equals 5. Excuse me, not equals. X is less than 5. Okay, the only difference is now I have to graph this. So the way you graph it is you draw a number line, right? And my expectation for your number lines is to have the positive value, a 0, and the negative of that same value. So when you are graphing inequalities, first you have to find the spot on the number line. It's a 5. This x cannot equal 5. So because it cannot, I have to put an open circle where that would go. And then I'm going to draw an arrow, a thicker arrow, to point to all of the values that x could be, right? Because 3 times this number has to be less than 15, anything less than 5 will work. 5 won't work because then it would equal 15, so that disqualifies it. So if this cannot be the answer, then you have an open circle. If it could be the answer, if it was or equals 2, then I would fill that circle in, and we'll do an example of that in a second. So here's our second practice problem. 2 minus 3x is greater than 23. Okay, so again, I'm going to draw my wall of equality. This is one of my favorite two-steppers. So I'm going to go about my business solving this problem. So now I have negative 3x is greater than 21. I'm going to divide by negative 3. And now I have an x and I have a negative 7. There's a little rule here. If you divide by a negative, your sign flips. So because this was greater than, now it's less than. And that's because I'm changing the whole value of the number, right? Because a positive divided by a negative is now negative. So I have to change my symbol as well. Okay? So we call that flipping the sign. And we only do that, again, when we divide by a negative. If this was a positive 3, then I would have left my symbol the same. But I had to flip the sign because this is a negative 3 here. So then I'm going to draw my number line. Again, I just need the number 0 and then its opposite. And this tells me that x is less than negative 7. So again, I have to have an open circle because it cannot equal negative 7. And all my values that are less than negative 7 go to the left. Okay, let's try another one. 7 times the quantity negative 2x plus 12 is less than or equal to 70. Oops, I'm sorry, you guys can't see that. There it is. So I'm going to draw my wall of equality just like I would normally if this was an equation. I'm going to follow all of my equation solving steps. So 7 times negative 2 is negative 14x. 7 times 12 is plus 84. It's less than or equal to 70. Now I've got a two-stepper. So I'm going to subtract 84 from both sides. Using my inverse operations, now I have negative 14x less than or equal to negative 14. Oh, I'm dividing by a negative again. So if you go back up here and look at your notes, when you divide by a negative, you have to flip your sign. So I'm going from less than or equal to to greater than or equal to, because this went from a negative to a positive, because a negative divided by a negative is a positive. So now I'm going to graph this, and this one's going to be a little bit different. Here's my number, 0, and its opposite. This is greater than or equal to, so because it can equal the 1, I'm going to fill in the point. And then all of the values that are greater are going to the right. So that's how I would graph that inequality. All right, let's do another one. I've got 8x plus 5 divided by 4 is less than or equal to 20. We haven't seen equations that look like this in a while, but we're going to solve this inequality just as we would if it was an equation. Since this whole expression is being divided by 4, I'm going to get rid of that by dividing this side by 4 and dividing this side by 4. Now I'm left with 8x plus 5 is less than or equal to 80. Now I've got a two-stepper, so I'm going to subtract the 5 from both sides. And I've got 8x equals 75. Divide by 8 on both sides. Oops, that should not be an equals. That should be a less than or equal to. So now I have x is less than or equal to 75 over 8. So I'm going to graph that just like I said before. I'm going to leave it a super ugly improper fraction. So I've got 75 over 8, 0, and negative 75 over 8. Right? I just have to show the number, 0, and its opposite. And since my symbol is less than or equal to, I can fill in the circle because it can equal the 75 over 8. And then all of the values that are to the left are less. Let's see what we've got on this next page here. Okay, I think we're going to stop right there. So if you can just make sure when you come to class tomorrow that you have all of the notes completed, and then we will practice, we'll go over these in class, and we will practice some inequalities while you guys are here. Thank you so much.